Hey everybody, today we're going to be looking at 7C. So 7C is going to be a calculator heavy unit or section. Go ahead and grab your calculator, or you're going to want to go in on your phone and download the TI-84 app from either the Play Store or the or whatever the Apple Store is. There is a free version. Get the free version. Don't get the paid version, but get the free version. It'll let you use the calculator at home. Go ahead and do that real quick. If you need to pause, go ahead and pause. The very first thing we're going to do on our calculator every single time is reset it. Here is the reset command. So we're going to hit second plus 712. So going over to my calculator, second plus 712. Okay, and then your screen might look a little bit different from mine. I did get a calculator that's a little closer to y'all, so it should be a little bit better, but that'll reset it for you. Okay, once it's reset, we're going to go over. Let's talk about what we're looking at in this unit first. So we're going to be looking at identifying key features of graphs based on an equation. So there's two big types that we're going to be looking at. The first is projectile motion. So projectile motion always follows this formula, where h of t is the height at time t. Okay, usually, or at least in this class, we're going to be doing this in feet. Okay, in your science class, they may do it in meters, but here we're always going to be in feet. This minus 16 is gravity in feet per second squared. In your science class, again, it may be a negative 4.9. That just means they're using meters instead. T is time, typically written in seconds, and for these problems it will be. VO, or V naught, is the initial or starting velocity. Okay, so if it's a positive number, we're throwing something up. If it's a negative number, we're throwing something down. HO, which is probably one of our more important numbers here, is going to be our starting height. Okay, so in a few minutes, we're going to be getting some problems, and it's going to ask, hey, what is the starting height? Which it's just going to be this number right here. Okay, so remember that for when we get to those parts. Okay, now that being said, there's two types of problems. Most of the ones we're going to look at in this unit are what we call projectile motion. Projectile motion means something's being thrown up, and then it falls back to the ground. Okay, so in the context of these problems, we're talking about a ground here. So typically on our graphs, we're going to see it keep going. Okay, but that last little part there would be if the ball was going through the ground. Okay, so typically with these problems, we kind of just cut it off right there, because while it might make a little bit of a hole if it's something that's really heavy, or it might bounce. Okay, the bouncing and the holes, that's something you would do in upper level physics. So we're going to be thinking of these as stopping here. Okay, now we will use the tail end, and I'll show you how to use that in a little bit. But that's the first type of problem. The second type of problem typically deals with money, but these are kind of just the other category. So I'm going to do this a little out of order. We're going to start with number 2. But for our calculator today, we're going to set all our x-mins to 0. Okay, so after we've reset our calculator, we're going to set the x-min to 0. To do that, we're going to click Window. And then we've got a bunch of choices here. The only one you should ever touch for what we're doing right now is this one. Okay, in a minute, we're going to be changing the x max on a couple of these, but don't touch any of this other stuff. What these do, so x-min sets the left side at whatever number you have, in this case 0, because we don't care about what happens to the ball or whatever before 0. X max would be where we would want to set it if we need to set it bigger or shorter, depending on the time it takes. X scale is what it counts by. So typically 1s here is a good number. And then the y min, y max, y scale kind of does all the same thing, but in the y direction. But we're going to let the calculator play with that. And then these last three down here, never touch those, because if you mess with those, it's going to mess up your calculator and your graph's going to be wrong and it's going to make your life sad. So please don't touch those. Okay, that being said, we've set our y min to 0. Yay. Again, we're not going to worry about, x min to 0. We're not going to worry about the y min because it's not going to matter here. Okay, and I'm going to start with number 2, and you'll see why in a little bit. So if you have a projectile motion problem, then the most important part of the problem is the equation. Okay, because really all of these problems kind of work the same. Okay, 9 times out of 10, as soon as you hit a word like flew, launched, tossed, thrown, you can stop reading. You can just look for your equation and you're good to go. Okay, so I start reading this. Suppose that the flare is launched. Okay, this tells me I can stop, look for my equation, and that's what I'm going to care about. Okay, so we're going to do this again a little out of order here. Everywhere we have a t, we're going to change it to x, because if we try to type this in the calculator, it's not going to work with t's. There is no t button that works for what we need it to do. So if I think about this logically for a second, let's go ahead and graph this and see what this kind of looks like. Let's try that. That should work a little better. Squeeze it in a little bit. Okay, so we're gonna, oh, this is really annoying. I don't like this. Okay, so we're just gonna have to do it that way. So negative, nope, sorry. Let's fix that. Okay, there we go. Sorry, go to y equals. We're gonna click negative 16 x squared plus 80x plus 224. Okay, and if I go to graph that, I'm going to see that I get this just downward line. Okay, now we said earlier that we should have a ball going up, or in this case, a flare going up and then coming back down. And I can't see all of my graph here. So what we're going to do is we're going to click zoom. And then if we scroll down a whole bunch, we'll see fit. Okay, so to select this easily, you can just hit 0 or go to it and hit enter. And then we get a graph that looks like this, okay? Exactly what we thought it would. 0 goes up, comes back down, hits the ground. Okay, now again, this tail part really probably isn't happening with a flare. It's not going through the ground, but it's gonna go up a little bit and then it's gonna come back down and hit the ground. Okay, so let's go back. We've got a sketch here. It kind of looks something like this. And again, we're gonna stop at the ground because it doesn't make sense to go further. So when we talk about the x direction in projectile motion, almost always we're talking about time, okay? And in this class, that it will be time, okay? In physics, you can talk about a distance, okay? But again, you would want to work with that out with your science teacher. Y here is going to be height. And for our purposes, again, in feet. Okay, so I've got a sketch in my graph. I got a general idea of what it looks like. Let's look at our questions. So these are the typical 4 questions you're going to see on pretty much all these problems. What was the height when it was launched? How long did it take to hit the ground? When did it reach its max height? And what was the max height? Okay, so what height was the flare launched? Well, I remember I told you to circle that thing earlier, right, on the end. It's right here. Start. So it was launched from 224 feet. Okay, now how long to reach the ground? So let's go take a look at our graph real quick. So if I look at our graph, I really should get, there we go. If I look at our graph, I can see that it looks like it hits at 1, 2, 3, 4, 5, 6, 7. Okay. Well, to verify that, we're going to hit second trace. Okay, now 3 things we're going to use today: 0, minimum, and maximum. Right now we're looking at a 0 because I want to know where it crosses the x-axis. Remember, zeros and x are the same thing. So what it's going to do is it's going to say, okay, what is the left side? I'm going to hit enter. And then it says, okay, well, what is the right side of where you want me to look? I'm going to hit enter. And it's going to ask you to guess. If you want to move it kind of towards the middle and make a good guess, you can. But that part really doesn't matter. You can just hit enter again. And we see it, in fact, it does land on 7. Okay, and in this case, 7 seconds. Okay. Now, just for clarification, because this seemed to help a lot of students in class, what the calculator is doing is it's saying, okay, you want to find a 0. Well, we have a 0 right here, and technically we have a 0 over here as well. Okay, but we don't care about that one because it's before we threw the ball or launched the flare. And you're telling the calculator, hey, I want to find this point right here. And the calculator says, okay, well, where do you want to look? And it says, okay, between what left side and what right side do you want me to look? So I want to pick a side over here somewhere. I want to say, hey, I want you to look in this area here. So here and here. So if we move that little spider icon to those spots, you say, okay, this is the left bound, this is the right bound. I want you to look in the middle of these two. Then it will find that spot for you. Okay, so you want to make sure on the left and the right. If you get an error message, then you probably didn't go far enough left or far enough right. In this case, it's better to be too far than not far enough. Okay, so our keyword for this next 2 parts is maximum here. So the great thing about the calculator here is it's the same idea. We're going to go second trace again, but this time we're going to select maximum, so 4. So I want to scroll over to the left. You can just hold down the button. Okay, my maximum's right in here somewhere. And again, it's better to be too far than not far enough. So I'll put the left all the way over there. And again, too far is better than not far enough. If I wanted to be really silly, I could get all the way over here and say, hey, I want you to look between those two. Hit enter one more time. And we get a really weird looking number. Okay, our y is okay, but it's the x here that's kind of messed up. So if you ever get 9999999 or 0000000, it's a rounding error in the calculator. So here we've got 9999999. We can assume that it is at 2.5. Okay, so my time here is 2.5 seconds. My height is 324 feet. Okay, so again, if you ever get that 99999 or 00000, it's a rounding error in the calculator. The calculator is confused. It can't find the exact number, so it finds the one that's the next closest to it. Okay, so now that we have that under our belt, let's go back to that first problem. So every time we do a new problem here, we are going to reset our calculator. So second plus 712. We're going to adjust that window minimum to 0. Okay, and then we'll go into y equals. So reading my problem, a model rocket is launched. So I can kind of stop reading there and go into my equation. Okay, plugging in my equation, negative 16x squared. Again, everywhere there's a t, we're just going to put an x, plus 160x. Okay, go to my graph, and I got 2 little lines on the side here that are not very helpful, so let's zoom fit that. So zoom, 0. Okay, so that's a little better, right? I've got this nice arc here, comes up, comes down, hits the ground. Okay, the problem's going to be on this right side. I don't have that tail so that I can do a left and a right bound. So if you ever have that happen, we're just going to make our window a little bigger. So I'm going to go to 11 here. I'm going to regraph it, okay? Well, that's a better area, but I still don't have the tail. So let's zoom fit it one more time. And there we go. Now I'll be able to figure out what that 0 is exactly. It definitely looks like it's 10, but it's always worth double checking, okay? So launched, we're dealing with projectile motion, so time and height again. This one looks like it starts from the ground, pops up, pops back down. Okay, so first question, same thing. What was the height of the rocket when it was launched? Okay, now the common mistake here is students go 160. 160 has the x. Remember, on our equation, it's the number without an x. So I can add 0 to this and not change it. So my height here is 0, which makes a lot more sense based on our graph than 160. So 0 feet. Okay, I could also read more of the question, and it says from the ground. Okay, how long did it take for the rocket to hit the ground? We're going to do the 0 function there. So second trace, 0. Put that spider on the left. Right about there is good. And again, as long as you're on the left, it doesn't matter. Too far is better than not far enough. Right, enter, enter. And our 0 is in fact at 10. So after 10 seconds, it hits the ground. Okay, when did it reach its max height, and what is the max height? So same idea, but with maximum. So max, move all the way left here. And again, too far is better. I wouldn't stop like right there. Keep going, keep going, keep going. Too far is better than not far enough. Okay, if you don't go far enough, it's going to find the maximum number, which may not be the actual maximum. Okay. So again, I got that 4.999999. I can assume 5 seconds at 400 feet. Okay. Now, this next one is not a projectile motion problem. I start reading the value of some stock can be represented by an equation where X is the number of months after January. Okay, so on these ones where we don't have a projectile motion, we want to underline important words, things like value, the equation's important, and the number of months. Okay, value you usually think of as in dollars, months we're going to talk about in a second, and we got our equation. Okay, so our X here, X is the number of months, so months. Y then has to be money. Okay, so new equation, and I didn't mean to click that. Go away, old crappy calculator. Second plus 712. Okay, I've got that reset. We're going to go into a Y equals here, or sorry, window first. Set it to 0 because we want to start at 0. Okay, and really what we could do here, because we're talking about months, we could probably set that maximum to 12 and it would give us a whole year. Okay, and then 2x squared minus 8x plus 10. Go look at that graph, and I got a nice little piece of a graph here, but not all that I need. So we'll zoom fit it, zoom 0, and there it is. Okay, so this one goes in the other direction, and that's fine. And that makes sense because usually you want stocks going up in value. Okay, so it goes down for a little bit, which sometimes happens, but then it starts shooting up. Okay, so I start a little high, go down a little bit, never quite reaches 0 that we saw in the original graph, and then goes up. Okay, so my questions here. What is the lowest value, and when does it reach it? Okay, so lowest meaning minimum. So same idea for the minimum as we did with the maximums. We'll put that spot on the left. Left, 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 left. And again, too far is better than not far enough. And then we'll go to the right. And hit enter one more time. And we get a minimum at 2, 2. Now, let's be very careful here. Because the X here is months. Okay, so and the Y here is dollars. So what is the lowest value it will reach? Well, that's $2. Okay, and that's coming from the Y there, not the X. And when does it occur? Well, it occurs in month 2. Okay, but let's read the question carefully here because it says where X is the number of months after January, meaning January is 0. So February would be 1. So this actually happens in March. Okay, last one with graphing. Pat throws. I can stop reading. There it is. Okay, reset my calculator. I'm going to do this one somewhat quickly. So if you need to slow me down, you can do that within YouTube. Second plus 712. Window 0. There you go here. Type in our equation, negative 16x squared. We've got a minus 30 velocity here. Okay, what that means is it's going to be thrown down, which if I read the question, it does say that as well, initial downward velocity. plus 350. Okay, graph that out, and not useful, so let's zoom fit that. Okay, so this one's a little better, but this is a huge tail here. Let's cut this off a little bit, because really after about 3.7, 3.8-ish, I don't care anymore. Let's cut off at 5. So we're going to set the X max to 5. We're going to resume fit so it fits nicely, and man, that looks a lot nicer. Okay, notice on this one how there is no maximum. The reason is on the other ones, it was thrown up and then came down, whereas this one's just thrown straight down. Okay, we still do have time and height, but hopefully this question doesn't ask us about a maximum, and if I look, it doesn't. What is the initial height, and how long does it take to hit the water? Okay, well, the initial height is just that last number, in this case 350. And to hit the water, we're going to do a second trace, second calc. We'll go down to 0. Put it on the left. Hey, it's already on the left. I can even do it all the way over there. Again, as long as it's on the left of where you care about and the right of where you care about, that's fine. Okay, that's more than far enough. And we get about 3.8 here. Okay, now the question comes up in class sometimes. Well, how do I know when it's kind of close enough and I should just use the number that makes sense? And how do I know when I should round? Well, one, the question should say round, and this one does. And notice how here we don't have a 99999 or a 00000. And because we don't have that, we kind of just want to take it like it is. So in this case, 3.8 seconds. Okay, for this last part. So those were taking equations and finding information about them. This is taking information and creating a graph. Okay, so kind of working backwards a little bit here. So a ball is thrown from the 5th story. So at 0 seconds, we're at the 5th story. Or we could say 0, 5. Okay, if this is time and this is height. Time, height, time, height, time, height. Okay, well, already we could actually kind of just guess with this one because this is the only one that has 0, 5 in the right spot. They all have 0, 5, but this doesn't make sense. This doesn't make sense. That'd be backwards. This doesn't make sense. Again, be backwards. Okay, so we just want to be careful here. Let's keep reading, though. Just make sure we got this. So after 1 second, it reaches 8 stories. So 1 second, 8 stories. So 1, 8. Okay, so it goes up, hits 1, 8. Okay, that tracks. And then after 3 seconds, it's at the ground. So 3 seconds, well, ground would be 0 stories. So 3, 0. So we continue on and we hit 3, 0. Okay, so this is going to be my answer here. Okay, in the homework, there was a mistake on some of the problems. You don't want to do 2C. And then you also don't want to do number 3. Skip these. Okay, if you have any questions, feel free to reach out to me, and I'll see you guys.